All right, hello. Welcome to the review of the FRQ from our test. So the first question for the non-calculator portion is using the rational function t given by here, where t of x is equal to x plus 2 times x minus 1 times x minus 4 all over 5 times x plus 3 times x minus 1 times x minus 3. The function t is graphed in the xy plane. Determine equations for all vertical asymptotes of the graph of t, or state there are no vertical asymptotes that exist. So first, we notice that this function is in factored form. And remember, what does factored form help us by finding? Again, we can look at the slides that we had. And here, factored form of a rational function help us find the domain, holes, zeros, and look at that, vertical asymptotes. How can this function help us find vertical asymptotes exactly? So we have x plus 2, x minus 1, x minus 4 all over 5 times x plus 3 times x minus 1 times x minus 3. Okay. Remember that the zeros is when the whole function is equal to 0, while the vertical asymptotes are just when the bottom is equal to 0. So what can we plug in for x, where we get the bottom is equal to 0, and what happens when the bottom is equal to 0? It's undefined. That's why we get that vertical asymptote. So we can just go one by one factor at a time. Okay, so we have x plus 3. What number can we plug in for x in this expression that gives us 0? Well, the long way is taking each factor and setting it equal to 0. Okay, turns out it's x minus 3. Who would have thought? X minus 1 equals 0, x equals 1. Then set that equals 0. Okay, so we have 3 things that make it undefined. However, it is saying just vertical asymptotes. If we remember, holes in our function appear when there is a factor on the bottom and the top that are the same. So x equals 1 is a hole in our function, so we do not include this as our vertical asymptotes. So literally, it is just x equals minus 3 and positive 3. That is all we have to show for this question. But again, showing your work is what is needed. All right, second part of the first FRQ, non-calculator, is now it's asking us to find the zeros. So we pretty much do the same thing, that same process as the last part, except now instead of what makes the bottom 0, it's the top 0. The whole function is 0. Okay? So again, just really quick, writing everything down. Boom, boom. Okay. Now we're just going to take each factor, set it equal to 0, solve for x real quick. And this will give us are zeros, right? All three of these make the top equal to 0, which will make the whole thing equal to 0. But again, just like the previous part, right here, x minus 1, the factor is on the top and the bottom. So again, same logic. There's a whole at x equals 1. Whoops. So therefore, we do not include 1 as our 0. So the zeros are x equals -2 and positive 4. Okay, simple process. You just have to know what to do. All right, last part. So now we have to determine if the graph of t has any horizontal asymptotes or slant asymptotes. Write equations for those asymptotes, or state that no horizontal asymptotes or slant asymptotes exist. We have to give a reason for your answer. So knowing what we have to find is obviously helpful. So first we have to figure out what is the difference between horizontal asymptotes and vertical asymptotes. Okay, so vertical asymptotes we just did, so I'll explain that. So again, that's when the denominator is equal to 0. Okay, when it's undefined. Horizontal asymptotes you can think of as the end behavior. That's how it affects the end behavior of our function. Okay, so knowing that, affecting the end behavior, we go back to our notes. Again, I'm showing you this because I want to prove to you that I'm not some type of math wizard. All you have to do is know how to read your notes. And going back to slides that we have done in the past. So end behavior for rational functions. So again, this is the slant asymptote case. If we look at the bottom here, note if the degree of the numerator is exactly 1 more than the degree of the denominator, then f of x has a slant asymptote. We go back. If we multiply all these factors out, all I care about is the leading coefficient and the degree. When we multiply this out, right, x times x times x, right? We're multiplying this out 3 times. So we have x to the power of 3 on the top. Same thing on the bottom. Right, x times x times x, and x times x. X to the power of 3 on the bottom as well. Then we have a 5. Okay. So we see that they're the same. What case is that? It's case 3. Case 2 is when the denominator dominates the numerator. That's not the case. Case 1 is when the leading terms have the same degree. Okay? So, and when that is the case, the horizontal asymptote is y equals a over b. And again, what is important is it does say justify our answer. In the scoring guide, it says that the response should include the horizontal asymptote and should also reference the degrees of the polynomial in the numerator and the denominator. So there's many ways to do this. If you want to be exact, like here, you can say like we have f of x, which is equal to a, and again, over b, and, whoops. So again, f of x equals a times x to the power of n over b times x to the power of d. Okay? You can always reference your notes. It is never bad. It's supposed to be an n, right? And n is equal to d, so there's a horizontal asymptote at y equals a over b. Just to show you different colors, it makes sense. Okay. B, right, is 5. A would be 1. Okay. I know what was fresh in our mind was long division, and we can find the slant asymptote using long division. But if we know this, it makes it a lot easier, because all we have to do is that it's a over b, so it's literally y equals 1 over 5. So this will get you 1 point. In some type of explanation, we get you that second point. So it's not just enough having the answer, it's also you need to know how to explain your answer in these FRQs. It's the last question of the non-calculator portion. All right. Second part of the FRQ, where this is now the calculator portion. So a new set of polynomials, f and g, are given where f of x is equal to negative 5 times x minus 2 times x minus 4 times x plus 1, and g of x is equal to 2 times x minus 4 times x plus 3, and then the rational function of h of x is equal to f of x divided by g of x. So the first question is asking us to graph f of x, determine the local minimum and the local maximum, or state that they don't exist. So again, local minimum, local maximum is located in a certain area, and where the global maximum is where you take in every single point that's possible and figure out what's the highest and what's the lowest. So typically, the function is going to look something in the lines of like this, right? So locally, you would isolate the humps of the graph. Globally, right, since it goes on to infinity, there really is no local min and max for that area, but it's globally. Okay? So, since this is the calculator portion, we could use a graphing calculator. And what I also found out is on your AP exam, you'll be using Desmos calculator. So that's what I'll be using now. It's actually a lot easier to use than you might think. And again, I should also restate that this question is asking us for the function f, not h of x. Okay, so the function f is, I believe it's negative 5 times x minus 2. X minus 2, x minus 4, and x plus 2, x plus 1. Sorry. So we have this graph. We don't even need to press any buttons after we enter in our function. What's also great about this is we don't have to press any buttons to find the local minimum or maximum. We know that relative local, and as long as you know where it's at, click on this point, boom, we have the local maximum point. Okay, go back real quick. Say local maximum 0.214. Again, 3 decimal places. Okay? No less. You can do more if you want, but definitely no less than that. Negative 41. No. This is my bad. Local maximum is 3.120, comma, 20.303. Oh no. Okay, that's the local maximum. Just zoom out on the local minimum. Boom, relatively, click on it, get that point. There it is, the local minima. Local min, again, 3 decimal places, 0.44. Boom. Here, this question just wants us the coordinate locations of the local min with the label and no others. So labeling, right, saying that it's a local maximum or local minimum, right? You can't just put the coordinate points. And that's it. That's it. As long as we understand what to do, we let the calculator do all the work for us. Okay, so the second question is in the plane of the graph of h this time, of the function h of x, where's the hole? What are the coordinates? Or not, it's not asking what are the coordinates. It has the coordinates of c comma l. It's important that we understand what this information is talking about. C would be the x value, okay, because it's going to come in handy later. It is known that the limit of as x approaches c, that's the hole of h of x is equal to the L, which is that output. And there are no consecutive integers, and that they are consecutive integers a and b, for which that a is less than L and b is greater than L. What are the values of a and b? Give a reason for your answer. And also consecutive integers, so that just means right one after the other, right? And they have to be whole numbers. So this one's looking for a lot. We'll admit this one is a little bit trickier. So first, we have to know how to find a hole. So let's just do some hand work before we use the calculator. Can determine the hole, right? The factor has to be present on the top and the bottom. And what linear factor is that? That is x minus 4. So when we graph this, we will see that portion. Let's graph first, and then I'll try to explain a little bit later. Okay, here hopefully if I just press divide, boom. And now I have to just put in 2 x minus 4 times x plus 3. Okay, zoom out a bit. This is what our function looks like. And I want the whole zx is equal to 4, remember? Okay, zoom in. Can I just put in a line of x equals 4? So here we are. So I can't draw on this. Okay, but you can see that we have 4 right here, and we just follow it down to our graph. Okay, if we click and hold on the line of the function as we approach 4, as x approaches 4, right? 3.9, 5.1, 3.57, right? What is the y value approaching? right? Negative 3.5, it looks like. 3.55. Let's see. Negative 3.569 from the left, and again you can do it from the right, above 4. Getting closer and closer to 4. The x value, again, look at the x value over here. As x gets closer to 4, what is y getting closer to? It's going to be the same value. Okay? Just say 3.571. Some approximation you'll be. If you're really close to negative 3.57, then you'll be good. So I'm just kind of just doing one thing at a time. So C, right, is 4. And here in this case, L will be negative 3. We're just using, should really state that this is an approximation. This is not an exact value. So I have C. So let me just write this. This statement, the limit statement, as x approaches, right, 4, h of x approaches negative 3.571. So now I have to find integers a and b. Okay? So the second part, I don't know what a and b is yet. I haven't tried. But I know L. What do a and b have to be? And that there are consecutive integers a and b, for which this statement is true. How is this statement true? What values of a can I put consecutive whole numbers? Right? Hopefully you can see what's a number less than negative 3.571? Negative 4, right? What's a number larger than negative 3.571? Negative 3, right? So then we state a is equal to negative 4 and b is equal to negative 3. Okay? So we have the values of a and b. So I verbally described why there's a whole that equals 4. So you just have to write it down for reasons why we have a full at 4. Since there is a factor in the numerator and denominator that are the same, then there is a whole at x equals 4. So this is a good reason. Again, this is not the only reason to give. If you have a better way to explain it, you can. And then the approximation for L. So we have the values of a and b, the reasoning of why we found 4, and the approximation of L. All three of these will give us those 3 points. Again, this one's definitely a little bit harder, but hopefully you followed along enough to understand how to do it with me, and it will definitely be harder if you try to do this by yourself. But hopefully this helps you understand and gets you a little bit closer to doing this by yourself. All right, this final question. Determine if H has any horizontal asymptotes or slant asymptotes. Find the slopes for those asymptotes, or state that no horizontal asymptotes or slant asymptotes exist. Okay, I would say out of difficulty, this is the second most difficult, but it's honestly not that far from the first question. However, you might honestly you might make it more difficult because you think you would have to use the graph for this. Since this is a graphing calculator question, you think, oh, I need to use the graph for this. Then you look at this and go, how can I tell there's a horizontal asymptote or a slant asymptote? I mean, there's clearly a slant asymptote, but it's like, how can you figure it out with the graph? Ironically, we don't need the graphing calculator for this. If I actually gave it to you and said, don't use a graphing calculator, I think you'd be better off if I said you can use a graphing calculator for this. So we just go back to our notes, right? End behavior is the horizontal asymptotes, remember? And we look, in this case, I should have done it beforehand, but h of x is equal to, right? Again, just talking about the degrees, right? We have x times x, and then x times x again, x cubed. Care about that leading coefficient. We do, we care. And this is x times x, and that is it. X squared, and that is 2. So here, right, where the top is larger than the bottom, that is when it's case 3. The numerator dominates the denominator. N is larger than d. And then look at that little note right there. If the degree of the numerator is exactly one more than the degree of the denominator, then f of x has a slant asymptote. And this result part is just saying that it's a over b times x to the power of n minus d. If you want me to show you exactly that, right? And then I'll even say over here, a is equal to negative 5, b is equal to 2, right? N is equal to 3, and d is equal to 2, right? Again, a over b times x, n minus d. And now we just plug it in. Plug and play. Negative 5, 2, x, 3 minus 2. Right? So therefore, the slant asymptote is y equals negative 5 over 2 x. All this is not necessary, right? You could have gone from here where h of x to your answer, as long as you understand it. But I showed this process to you so you can better understand it. So again, this is a lot easier than the second one, definitely. Just don't make it harder on yourself thinking that you have to use the graphing calculator for this question. Okay, so that's the final question, final part of the FRQ portion. So please make all your corrections as needed. Thank you.